Hello, everyone. Welcome to a very exciting episode of Observable Flutter. My name is Craig LeBenz. I'm your host, as always, so far at least. Maybe one day someone will sit in the hot seat and host an episode. But for now, I am very excited to bring you Erick Zanardo, the TL of the IO Flip project at Very Good Ventures. We've got a lot to talk about today. It's going to be a little more interview style than past episodes, but I'm really looking forward to hearing all the juicy behind the scenes stories, anecdotes, all the things. So last note before we dive into this too much, remember everybody, this is the Flutter community, and on Observable Flutter, we're all here to discuss technology, learn from each other, whatnot, but we're not putting down other technologies that we don't personally use, whether that's other frameworks, other libraries, other state management solutions. Okay, I don't think we're going to have to worry about too much of that today, though. Today is just very fun. Talk about IO Flip Day. All right, so I'm going to bring in Erick, and let me make sure I'm on the right setting here. Here we go. Erick, would you like to say a few words to introduce yourself?
Hello, folks. Yeah, very nice to be here. I'm Eric. I have worked with a great team of other engineers on the IO Flip team, on the IO Flip game, and yeah, very happy to be able to share some experience here with you all.
Nice. So there was Geez, where to even start? I think one thing we were brainstorming before the episode was that we might begin by just playing one round and talking about the rules and whatnot, just to make sure. I doubt anyone has found their way here without having seen the game yesterday, but who knows? So Erick, you're going to do the honors of walking us through one round of the game.
Awesome. Yeah. So when you land it at the page of the game, you first see the leaderboards. You can also, check the rules because we have some, like elements in the cards that interact with each other. So like fire beats air and metal and stuff like that. Air beats other different elements and so on and so forth. Once you learn the game, you can just hit play, accept the terms, and then you first you are greeted by this beautiful owl, which is the card master of the game. So the idea, the lore of the game is this owl is who creates the card and all the beautiful image that you see in the game. Then you have to select a couple of terms. So first you select the class of your character. I'm gonna pick pirates because pirates are cool. And
Yeah.
dancing pirates seems like a good choice. I mean,
What
and
is this?
then
Pirates of Penzance?
and then you get a 12 pack of cards to choose from. So you can cycle through them, choose the ones that you like the most. I'm gonna try my chance here and pick the ones that I find the stronger one. So we have this Dancing Spark. Oh, this Dancing Energy seems good too. 86, 83. Oh, this is better. So I'm gonna exchange that one.
That's a big
Oh, this
upgrade.
is even
Oh,
better.
a foil. Let's go.
Oh, that was lucky. Yes. Cool. So I'm happy with my team. That's a great team. And I'm gonna join a match. Will take a couple of seconds and yeah, we are throwing the game. So players play at the same time. So I'm gonna start with Dance Spark. My opponent gonna
Opening
choose
with
their
your weak
cards.
card. I like it.
Yeah. Yeah, so like I mentioned, elements interact with each other. So water is weak to metal. So my card lost 10 points and eventually lost to the other one.
All
I'm
right,
gonna
pressure's on.
go, yeah, I'm gonna put some pressure and play my stronger one. Uh, yeah, take it. So Spark is Earth versus Fire. I won this round. So
Earth.
it's ties. And my last card
Oh, let's
Oh,
go.
I won the
Also, yeah,
match.
water there. Fire had a rough go in that game.
Yeah, yeah. I'm glad because I didn't have any. And then I can choose to go to next match, just with my score. And yeah, that's it.
All right,
That's
so
how
you got a
you
streak of
flip.
one going here. So
Yeah.
Very asks, she said, I've never seen hollow. I guess it's hollow card, right? Holographic.
Yeah, it's a hollow. That's how you call it.
And how rare are they? It was originally going to be 1%, but Eric, didn't it get changed at the last second?
Yeah, so every time a card is generated, so this happened 12 times per deck, you have 5% of a card being a hollow.
So across a whole deck, a pretty good chance, but there's it definitely went up a lot. I've seen people get 3 hollow cards and then they just play nothing but hundreds the whole game.
Yeah, yeah. I got myself in a situation, but the opponent got 3 hollows, so that was not that cool. But yeah, you can get 3 hollows.
I'm playing with my audio here. Oh no, that's in the right setting. Okay. Oh, I see. Okay, sorry. Miss a distraction there. Okay,
No
so yeah, that's
problem.
one game. Your streak is up to 1.
Yeah.
And all right, let's talk a bit about everything that went into this. So you you mentioned, and I heard a little bit this from Jay as well. And for those who don't know Jay Chang, he's a marketing wizard, honestly, on the Flutter team. He was the original brainchild behind the pinball game that was also built by Very Good Ventures, and a lot of the cool stuff that Flutter does. But Jay and folks at Very Good Ventures, you were all iterating and trying to figure out, like, what are we going to build this year, and take me through some of the early ideas and different trade-offs that you were considering, and how you ended up actually settling on IO Flip.
Yeah, for sure. So the first couple of weeks of the project was very cool because like we were just like brainstorming ideas, trying to think what could be a good fit for these years even, because the only thing that we knew was that we want to use AI and machine learning generative things in the game. That was our only like requirement to develop the game. Everything else were open, and we could try to think on ideas and propose the game around that. So as you can imagine, if it's something so broad like that, many ideas came into play. So we have many sessions of brainstorming and discussing. We had awesome ideas. Like one that really liked it was kind of to build like like that where is auto game where you need to find
Mm.
auto in a crowd and different things. So we thought that maybe, hey, we could generate these backgrounds with generative machine learning algorithms. It could be dash the one that we need to find, and things like that. We also thought on maybe like we could use like generative machine learning language models to create an adventure. So imagine how cool it would be that we could have kind of an RPG game, that where the quests are all generated by language models, and the backgrounds, all the places that
The
you
scenes,
travel
yeah,
to.
yeah.
Yeah, would be generated by image generation algorithms and things like that. And the card game was also presented since the first ideas from the first iterations of our brainstorming, because like a card game, usually card games have a picture of, they have a theme, and they also have descriptions, names, and things like that. So we also found it should be a good fit for the for this requirement that we had. So we went throughout. Then we made some prototypes, some POCs. Like we built a small where is Zelda where there's a lot of that you running through the screen. It was fun to see that. We started even without any machine learning, just some procedural random algorithms just to validate the idea. So we went back and forth. We have many ideas, and in the end we went up to choose the card game because in a way it's a simpler mechanic, right? So like in an IO game, usually we try to make the game simple so people can quickly get it, play, repeat it. So the this was also one thing that we try for a lot to be a repeatable experience. So you can play one quick match, but that's so cool that you want to play another, but they never last that long. And that was something difficult with, for example, the other ideas. So where is Dash or where is Aldo games? You can spot the what you are looking for in the first second, in the first minute, or you can spend like 10-20 minutes trying to find them, or on a adventure like on an RPG game. Those they are telling stories and don't want to rush through stories, so those would also take too much time and would not fit that well into what we were trying for. And so the card game kind of fit very well on. Would be able to use machine learning to generate the cards, to generate the illustrations of the cards, and it would also be something that could be designed to be a quick experience that could be repeatable. So we kind of keep to that idea. In the beginning, it wasn't really what we have right now. We run through a different iterations of card games. So the base idea was a game that I used to play on my childhood a lot that is called Super Trump, or Top Trump in English, I guess, which is basically, yeah, it was fun because I didn't knew the game in English because I'm not a native English speaker, so I come from Brazil, and the game has a different name there, so it was hard to explain to the thing, and then we discovered that in the US, the game is called Top Trump. And the game is about, like, you have a thing, like for example cars, then you have a deck of cards that represent cars, and each card has a set of attributes like horsepower, top speed, acceleration, weight, and things like that. And each turn a player chooses one of the attributes, and whoever has the bigger attribute, the highest attribute, wins that round. So that was the basic for idea. But in the end, we iterate over and over and over and landed on the mechanic that IO Flip is now.
Nice. So, wow, there's a lot there.
Yeah.
One thought, by the way, when your hands hit the desk, it's sending a bit of a thudding noise through your microphone.
Oh, okay.
I'm a hands,
Okay.
yeah, I'm a hands talker as well. But okay, so you settled on this game. First of all, the RPG next year sounds really fun. I have no idea if that'll be the right thing or whatnot. I can imagine if the Flutter scene situation is ready to go, could do some pretty fun things there. But so you settled on this card game, and Very Good Ventures is in either Flutter first or exclusively Flutter development shop.
Yeah, so I definitely Flutter first.
Okay.
I don't really know if you have any other projects than Flutter. I don't think we do, but yeah,
Okay.
that is definitely our focus right now.
Got it. So Flutter was the obvious choice then for the front end. But tell me about how did you make all the decisions? What did the rest of the tech stack look like? And how did you kind of settle on those things? What constraints did you anticipate dealing with? Like, walk me through the non-Flutter parts as well.
Yeah, for sure. So yeah, Flutter was a given because, well, this was a Flutter showcase, so this was the choice for the client. We also knew that we wanted to use Firebase because, as always, we also want to showcase Firebase use on those projects. So we also knew that we would want Firebase for, whatever we could use from it, right? Firebase has a bunch of different features. So one that we were for sure that we would use would be Firestore to hold the data, to do the queues, the insert, all the data would be managed by Firestore. And we also knew that we would need a backend for this project. So because this is a game where players play against each other, so we need to do validation. So we couldn't leave all the game logic in the client, because if we did, people could try to take a look on the source, try to find ways to exploit the game and take advantage over their opponent. So we knew that this would need to be a server authoritative game, right? So all the logic would be defined by the backend. So who won, who wins a round, who wins the match, it would be the backend who would know that. So once we understood that, we start to think like what we going to use for the backend. Our first idea was to use Firebase functions. This was like already something that we proved in the past that works great, is easy to use. But this game, unlikely the other project that we did for this kind of thing, would have way more need for it would be like a bigger backend than the other. So we wouldn't need a bunch of Firebase functions. And since at VGV we are very focused on Flutter, on Dart, we don't have that much experience with TypeScript, for example, which is the language that is usually that we see more people using on Firebase functions, right? So we were kind of worried a little bit about going through like building this whole backend with a language that we are not so used to. So I started considering to use like a Dart backend. On top of this thing that I mentioned to you, that the team was not that experienced with TypeScript and using Dart could give us an edge, we would also be able to share code between the server and the client. So when we realized that, we said, okay, so that is, I think, like the right choice for this project. So let's make a backend of this project using Dart. And since inside VGV we have been building Dart Frog, we went with that because we have more experience with it. We have people that can support us if we need any help. So yeah, and that's what led us to go to the Dart backend.
So you had a Dart backend, and I think one thing a lot of Flutter developers, especially those who use Firebase, long for is, yeah, a Dart to be supported in Firebase functions and whatnot. And you had, it sounds like you achieved a similar setup by using Dart in Dart Frog, but you didn't, you weren't using Firebase functions. Of course, it's funny. I know you deployed Dart Frog to Cloud Run, and Firebase functions runs on Cloud Run under the hood.
Yes.
So, the difference between what you did and Firebase functions is not, there's only a few differences that remain. But one of those is like the subscriptions, like alert me whenever a document changes in a given collection or, stuff like that. So how did you handle talking to Firestore from Dart, given those limitations?
Yeah, that's a great question. So one thing that we decided to do is that all the sensitive data operations involving writes and updates and deletions would be done by the backend, but the client would have full read access to the entities. So that gives us the flexibility, for example, to create an endpoint on our backend that is responsible for when the player plays a card. So this is a sensitive operation, right? Because that's exactly where players may try to exploit the game and try to take advantage. So that operation, so the match and the match state cannot be written or updated from the client. They need to go through the backend, where we have set all the validations, all the security things regarding the game and authentication and all that stuff. But they listen to the match state updates from the client, so they don't need to go through the backend to listen to those changes. So the read access to those entities on Firestore, they are available in the client, so we can take advantage of the real-time capabilities of the Firestore database.
Interesting. Okay, so what I'm hearing is the flow would be the client, when a user plays a card, the client would send that information not directly to Firestore, but to Dart Frog.
Yeah.
And Dart Frog would verify things like, yes, this card was actually in your hand. You haven't already played this card, whatever else.
Hmm.
You are who you say you are, even though it was
Exactly.
anonymous authentication. Um, and then that Dart code, you probably must just use like the raw gRPC stuff to write to Cloud Firestore. And then the client had a live subscription. So how did you handle, maybe you just had two collections, like two documents for each game, but I'm thinking like another possible way to cheat. Let's say player one plays their card first,
Hmm.
and what you want to have happen is player two sees that a card was played, but they don't know which one yet. And did you actually send the right did you send which card information to the other client but then simply not render it, or did you even send more primitive information like, yes, they've played their card but we're not going to tell you which one yet?
Yeah, we send the whole information. So, but we send them encrypted and only the ID. So this is interesting because when that's why we have two different. Well, actually, not only two, we have multiple entities in the database. So when the player tries to get the full state of the match, which contains all the cards of their opponent, all the cards of their own hand, we send that whole information to the client, but that's encrypted. And then when a card is played by their opponent or even by yourself, that listener is triggered by Firestore, but you only get the ID of the card that was played. So their ID is not encrypted, so you can see what their ID is, but like it's just a number, or actually like a
Big
string
long
hash.
string.
Yeah, yeah.
Yeah,
So you will not be able to understand like what this is. So
got it.
that's
So
how
you
we manage
used
that.
Firestore slightly like a relational database, I'm guessing, where that was just a pointer to the card that lived in another
Yeah,
collection.
in
Yeah,
a
yeah,
way that there is a relation happening there because
yeah,
we send IDs and yeah. But that's how we
yeah,
manage to get around those things.
yeah. And that makes sense. The Cloud Firestore, of course, lends itself to um, not having fully normalized data to heavily denormalizing data, but occasionally you will
Hmm.
have little bits of normalization like
Yeah.
that. Um, okay, so the next thing I was wondering about your backend is the statefulness of the 10-second countdown. If you have one thing that a REST server is not very good
Hmm.
at is statefulness because it's intentionally stateless, and something like a countdown. Once the game starts, how did you have the server enforce the fact that after 10 seconds, what if both clients cheated and they blocked any communication at 10 seconds? Did the server have something up its sleeve to force the end of the hand?
Yeah. So the the backend does not enforce the counter. This is the something that the client triggers to us. But if they want to kind of miss their like trick the backend into thinking that they did not send a match, the backend will then send in an error, and the match will not go on. So if a player
Mm,
tries to cheat, that the match will be left in an inconsistent state, and so basically they can break the match, but they will gain nothing from that. So if they try to do that in a way, there will be no way for them to gain from that, so they will lose their streak. So yeah.
mm. Okay, all right. So cheating would only hurt yourself.
Yeah, basically. And we also
Okay.
implement a couple of measures in the client that, for example, if I don't get a play, I call the back and say, hey, is there a result that I missed? Maybe our information has been missed
Hmm.
or something like that. So the client does send a couple of requests to the backend to try to verify if the client is in valid inconsistent state to try to fix that.
We just got one question. I think I know the answer to this, but I'm going to let you field it, of course. Did you use Flame? And if not, what were the factors in that decision?
Yeah. So yes, we did use Flame, but it was only for the animations, for some of the animations. So I don't know if you remember when I showed the game when a metal card face against a ground card, a earth card. I don't remember the
Yeah, one of
relation
them.
of all the elements. There
I
are
think it was
so many
water.
relations. Yeah.
Yeah.
So the animation of or the water one versus the fire, where the water like
Yeah, puts
hits
out the
the
fire.
card like with a splash, and that. So that
Hmm.
animation is done via sprite sheet animation, and for that we use Flame. For the everything else, we use just plain Flutter. And the decision behind that was that this is a card game, so the game is kind of a turn based, right? So the turn happens at the same time, but until a player chooses a card, there's nothing happening in the screen. So we're just waiting for the players to play something. So there was no really the necessity for an active game loop engine like Flame is, right?
Mm-hmm.
So we figure out that there was much of a reason to use Flame other than this for the sprite animation ones, which we
Got
could
it.
also just implement a sprite animation just using Flutter. But since Flame already has that, so why would we reinvent the wheel? So we just use the package.
So um did you turn off Flame's game loop or did you let it just spin and do nothing?
Yeah, so in Flame, like Flame is just a widget, right? So when you are building a Flame game, you have the Flame game and you have the Flame game widget.
Mm-hmm.
And the game loop will just run as long as that game is attached to a game widget. So the game loop is running when animations are in the screen. Once they are disposed, the game is disposed together. And Flame out of the box provides a sprite animation widget, which is that sprite animation that you render in a Flame game, but in a
Mm-hmm.
widget, which is just like a convenient helper for you to use directly in a Flutter app if you want to show a sprite animation that is not inside a game, but you want to show like in your widget tree.
Gotcha. We got another question from a Flame expert. How is the
Yeah.
foil effect applied to the cards? This could be a leading question. Was it done through a custom painter?
Yeah, so I can show the code for that if you want to, but it's
Sure.
I,
Yeah,
I
yeah.
yeah, let me bring my editor here.
I'm ready for it when you. All right, there we are.
There we are. So before I go into that, I didn't work very deep on this, but I can give a broad idea of how I implemented that. So let me bring the card widget, which is this one, but I want to show you the file shader one. So basically, this is the widget that applies the shader to our card widget, and we just have some basic attributes here. The path for the shader itself, and this is done by using everything that Flutter provides to us out of the box. So we have this shader builder, which we need to return a sampler, and then we just use the animated sampler, passing all the required attributes that the shader requires. And we can see those attributes if I show you the shader, which I will not try to explain because that's too complicated and I don't really know how shaders really work under the hood. I know how to put them in a Flutter app. Where is the
Yeah, I was just
patches?
actually producing some shader resources earlier this week that'll come out later this
The
month. They are, they have a steep learning curve, let me tell you what.
yeah, they are not that
Random.
simple. You see, I don't even have syntax highlighting
Syntax.
for shaders. I should have, that's my fault. But I mean, we can try to understand it a little bit. So you see, like we have this rainbow effect attribute function method, and this does a bunch of image processing code.
Hmm. Hmm.
And yeah, by just taking this file that's written in shader language and put it with those.
Wolfenrain says shaders are easy once you sacrifice your soul to the shader god.
Yes, exactly. And I'm not
So
really
just do
ready
that,
for
Eric.
that yet. Yeah. So
um,
yeah, that's super simple
so
to put it. Yeah.
there's one thing in this file that I do want to just spend a second talking about. A lot of the heavy lifting is done by there's two widgets here that if you haven't seen are going to be a little confusing and hard to parse. So the shader builder, that one's a little easier to maybe imagine. That
Mm-hmm.
compiles the shader and just makes it available to your app.
Exactly.
But that animated sampler is kind of a crazy one. So what the animated sampler does is first renders something in your Flutter app, and then it applies a shader to what that original widget would have rendered. And we can see the animated sampler takes two parameters. The first one is a function, and it goes from lines 4 to 15. And so that's you. This could have been called like an animated sampler builder, and that would have been the builder method. But it's just a positional argument. You can absolutely think of it as a builder. And then on line 16, the very bottom line in the file right now, we can see a child is passed in. So that's the widget that the animated sampler takes, renders, and then applies the shader to. So that's how a card could get passed in here and suddenly have the foil effect drawn on top of it. And it is honestly all a lot. I happen my we just released the Flutter team released a bunch of talks yesterday for Google I/O. Mine happened to be about exactly this stuff, which is the only reason I even know what I'm talking about right now as I look at this file. I had to learn it to put together that talk. But anyway, yeah, if you're interested in how the foil effect would be done and shaders in general, you can check that out. It's the Next Gen UIs one. Anyway, yeah, animated sampler and the code inside animated sampler is bananas.
Yeah.
Some of the least intelligible. I mean, it is wild. It is really, really wild stuff. But that's why the Flutter team made it, because the engineer that wrote that widget was like, he's so deep in the rendering pipeline and all the things, and he just said to himself one day, no one will ever figure this out if we don't offer it. So just stapled together these kind of primitive helpers. All right. Anyway, so shaders, that's how that was all done. Okay, let's see here. So we know that you've got Flutter on the front end, obviously. You've got Dart Frog on the back end, but Dart Frog is only half the back end. Firebase is the other half. You're using Cloud Firestore, and presumably maybe a couple other products as well. Probably not any functions. Maybe though.
We eventually use Firebase functions in the end to make the scoreboard. So in order to also avoid the cheating and all that stuff, we made that the scoreboards are set by a Firebase function that is triggered for on write that happens on another entity that is also managed by the backend. But yeah, we end up using Firebase functions on this small piece of the whole thing of the game.
Yeah, I was just going to answer a question in the chat. Someone said Jonah is a whiz, and I have to type here, yes, Jonah is. That is who, and the theme is Synthwave 84. But this is not my theme currently on screen. So what theme are we looking at right now, Eric?
That's it. That's the one that is it, Synthwave 84. But this is not VS Code. This is Vim. So
what's the name of this color scheme?
Yeah, it's Synthwave 84. Is the
oh,
same
this
name.
is Synthwave as well?
Yeah, but for Vim.
Got it. Okay. All right. Well, yeah, there's that purple. Okay. I feel like I get more pink in mine, but yeah, I guess it's just a slightly different take.
Yeah.
Cool. Synthwave developers unite. All right. So let's see here. I'm trying to think about other things. Now I heard you also used the You also started with the
Oh my God.
casual games toolkit. Oh, we got a runaway AirPod.
Just a minute. My AirPods just fell off my ear. Sorry about that.
Yeah, they love to do that. They don't fit in my ears either. I don't know.
Yeah, that's odd.
I don't have the blessed ear shape, I guess.
Yeah.
Apple AirPods, I put them in, they're just like, see ya, and they jump right out. So I know, well, I gather that you all used the casual games toolkit.
Yeah,
And
indeed.
yeah, what was that experience like?
Yeah, it was great. So it's very easy to get it set up. You just need to get a template. We get that. We got that from the website. Everything is super well explained. The only unfortunate thing was that the toolkit's very like the idea of it is to help a lot of the things that mobile developers will need. So it helps a lot if you want to have like ads and integrate with the Play Store game services or app, the one from apps that I don't remember the name as well. So since this is a web game, we unfortunately was not able to take advantage of those features, but it gave us a really good edge on the audio setup because audio setup on web is, especially on web when running on mobile phones, can be a little bit tricky, a little bit buggy. And the casual games toolkit already have all that figured out. We have a audio service class here that I can even show you since I still have my code on. So here you go. We have this great audio controller class that handle background music, handle sound effects ones, to handles already integrates with assets controller that also came with the casual games toolkit. So all this setup to make games, the game play a music, play sound effects, and give the ability to the user to mute them, to disable sounds. All of that was figured out by the toolkit. So that was a great, head start that the toolkit gave to us, which is what the toolkit's intent for, right? To not build your game, but give you a head start and don't need to worry about those setup things that all games will need to have.
Yeah. So yeah, nice by the way that you all finally got to take advantage of a head start block of code from someone else, since you have a very good start package, or I don't know, template that you offer for everyone else to use. So let's see, gosh, there's so much more that went into this game. So the AI integrations, one thing, because a lot of this was done on very, very, very early AI products that aren't fully released yet and aren't fully safety tested yet. What an early decision was, well, first of all, the earliest vision was quite a bit bolder than the game ended up being. For those who don't know, originally the original idea was that users would kind of type in freeform what they wanted their character to be, so you could really get imaginative and had type different just string answers for powers, and then images would be generated in real time. That was the goal. That ended up being a bit of a challenge, both because the models are so new and weren't fully safety tested. And so it was moved to having all of the AI generated art and the character descriptions that were written by Bard, the Palm API. That was all pre-generated. So still done by an AI, but ahead of time. And that's, then we got the drop downs. So it's like, we're going to pre-generate for these specific things, because you can't pre-generate for the entire universe of possibilities someone can type in. So what was it like for the team as you were kind of moving around this, as the goalposts basically were just being moved on what the AI story was going to be? Because I know that was in flux for, pretty much up until the final word, until the final launch. So what was that like on your end?
Yeah, so this was an interesting story for us because like at the beginning it was like you mentioned, so they would be generated via in real time. So we would be given a service that given a prompt we would get an image. So that's a quite a simple integration from application perspective, right? We just need to call an API, get an image, probably save that
Yep.
image somewhere, so we don't need to keep calling that to get the same image. So that was kind of given to us. So we on the beginning of the project we just mocked this service. We create like a super simple endpoint that would return a hand-on image just to try to simulate what would get in real life, and we move on with the development of the game. We got very far just by using those mock services. Then we decided to go through that generative stuff, and then we had to start to brainstorm on how to use that. So after a couple of talks we just realized that okay, so we're going to give you some images that will follow a pattern on their file name. So basically like the file names are named like character underscore character class underscore their location, if I remember correctly. I think that's the pattern. Then a variation, because you have multiple variations per prompt combination to give the players the, like, look how many images we got from this pre-generated. It's still pre-generated, but there's so much randomness that the idea was that the player would not even realize that. So it was, once we figure out that pattern, that we got to the agreement of how the cards would be made, it was a simple change because we just need to get the prompts that the client side would send to the backend, assemble the URL, and then we would just fetch on the cloud storage. And we thought, okay, that's simple, we are good to go. Then we start to generate the images, and we start to realize that we had like thousands of images. Like, if I remember correctly, we had like 10,000 images or something like that. And then we start to, yeah, a lot. And then we start to get like, okay, we need to put that somewhere to host that somewhere for the app to get to be able to access that. So this started us to think better on another part of the project that's not even the client side, not even the backend, but all the things that we did to make the generative stuff, the pre-generated stuff available to the game. So I made a lot of scripts to try to upload the images, to upload the descriptions in Firestar. And we had to start to find smarter ways, because the first script that we did to upload the images, I realized that it would take, I don't know, a couple of years to upload everything, because there was so much data to upload. And then we started to do some research, to figure out better ways to do the upload. We did many scripts that would normalize the images, because sometimes the images didn't come with the standard that we had agreed upon with in the start. So we had to make some script to make sure that the images were correct. Then eventually we started to see images, cards generated without images. I said, this is not possible, because all the images follow a pattern, they should be met. But there are network errors, there are human errors that we don't account for. So start to realize that we had many missing images, many missing descriptions. Yeah, so then we went and make more scripts to validate that. So a script that would run through our database of prompts and check if there were images there. And then that was still not enough, because we started to get, hey, we can get some images, we can get better variations. So like for some prompts combinations we have 10, 12, 20 images, but for some others we have just 8 or just 4. So that makes our code a little bit more complex, because how can the code know, how can our application knows which combinations has 20 or 30 or just 10? So we figure out a way to like create a kind of lookup tables in Firestore that would storage how many variations per prompt combinations we had. Yeah, so in the
Yeah.
end, the solution is quite simple. We just have a script that runs through a folder, creates those lookup tables, upload them to Firestore, then the backend simply gets the prompt, do a query on Firestore to get those lookup tables and return the image. But the process to get to this complete solution was an interesting one to go, because we were also always learning, because the volume of the data was incredibly big. Like I mentioned that we had 10,000 images, which seems a lot, but for description we had 420,000. So yeah, it took me 1 hour and a half to upload them all to production.
Yeah, I bet. There was a I know the folks on Google's end who were manually looking at all of those images and
Yeah.
confirming that none of them had anything weird or, just inappropriate.
Mhm.
And those people's brains turned to mashed potatoes by the end of the by the
I
end of the
can imagine.
process. Yeah, they looked at so many pictures of, Dash and Sparky standing in front of a Disney castle, basically. And it's just like,
Yeah.
ah. Okay, we got some good questions in the chat. Randall asks, in the spirit of this all being an AI themed IO, did you use any code assist while writing this game? Copilot, Bard, ChatGPT?
Yeah, I use Copilot because I have access to it because of the open source program of Copilot. So yes, my answer would be yes, I use Copilot.
Nice. Yeah, AI to write AI code.
That's
Um,
scary.
okay, this is $1 million question. Melanie asks, how long does it take to develop this game? And we could spend the rest of the time, I think, talking about the answer to this. I'll rephrase this first. I think this question can take a lot of forms. First, I'll say, how long did you have?
Yeah, so in amount of months, we had 3 months for everything from ideation to the first prototype to the final thing. But we had many phases, so like we we changed the like I mentioned, we went through many ideas, we tried many different approaches. Even when was sure that this would be a card game, we still changed the mechanic a little bit. So I would say that for the final thing, like once we were sure what we are would going to do, I would say 1.5 months more or less, maybe a little bit more. Yeah, something like that.
Oh my gosh. Oh, 10 minutes if you fork it.
Yeah, that's
Oh,
true.
that's funny. Um, although that's a slow fork, gotta say. The fork button in GitHub is faster than that. So okay, 6 weeks I'm hearing is how long you actually had. Uh, how long would you have liked to have had?
That's not a fair question, because now like we know everything, right? We not know anything, that's a bold thing to say, but we learn a lot during this process. So like right now we could make many things different, we could improve many things, like I mentioned, all those script stuff, like that went like 1 week to figure out what would be the best way. So right now, if I would do this again, we would probably do this the right way, like right from the beginning. So I would say that 3 months is a good time frame to build something this size. Of course, everything that I'm saying is not taking into account all the work that Google did about the machine learning stuff, about the models, and you know that area I would not dare to give
Yeah,
a
that's
time.
true. Because folks on the ML side from on Google's end. We're working on that pretty much nonstop, trying to meet you in the middle, essentially, to figure out how that was going to work.
Yeah.
Yeah, that's true. So then, okay, so you had 6 weeks, and I think one of the trickiest things at the end was the matchmaking.
Yeah.
And I remember thinking matchmaking would require itself weeks of load testing and probably would require its own team, honestly, to like completely to get matchmaking totally right. And with so little ramp up period, it's like no one knows about it, no one knows about the game, no one knows it, no one knows, oh, everyone knows and everyone's
Yeah.
playing. And so just figuring out, did we engineer a system that can go from 0 to light speed in seconds is, I think it is just genuinely not possible. So I know matchmaking was one of the biggest headaches down the stretch. And I think, honestly, that probably would have needed its own 6 weeks minimum period to totally get right. But yeah, that was, gosh, there was a lot of complexity in this thing. Just to flip over a couple cards and see, is my integer higher than your integer?
Yeah.
A lot went
No.
into it.
Yeah, I mean, all multiplayer games, sorry, all multiplayer games have a complex of their own, because when you think like that you analyze things the way you mentioned, like it's just two integers to compare. Yeah, but like those integers will come in random times of periods of time. Like, so the timeline of the things are the trick part, because we need to take account about inconsistencies. One interesting bug that we had was that it seemed that your opponent played a card before you, but then it showed after, and then the game state was all messed up. And that was happening because something that we didn't even know could happen. Like a state that was triggered by Firestore first arrived after in the client. So the client would be receiving two triggers, but in a wrong order. So that completely messed up with the game logic. And we had.
How did you fix that? How did you account for that?
It was actually a quick, a simple solution. The trick part was to realize that was the bug. So once we realized that was the issue, it was simply a matter of, okay, let me check if this state is outdated. If it is, I just discard it and don't even consider for the game, because the states are always triggered correct. So I wrote the state first, then I wrote the second one. So this second one is correct. It contains all the data from the previous one. But they arrived in a different order. So what was happening was that the client was being, the correct state would be overridden by the wrong one.
Yeah.
So it just had to discard the incorrect one. But
right.
The trick part was to realize that was the issue.
Right. Yeah, it's a, oh man, if your game state is terse enough that you're able to send the whole, the whole universe goes out with every communication, then yeah, that certainly makes that a lot easier. But the trick with sending the whole universe out with every communication, like it sounds like, okay, well that's easy, but I imagine you may have also had things where, if the server didn't get, if the server screwed up in any way, like you said, just like a write fails or something goes wrong, there's no way to kind of reconstruct what should have happened. You're just lost at that point, I'm guessing.
Yeah, and that actually happened. So there was one edge case where the game would be over, but that would be no result on the document that the client received. So we did some things to solve that, which was basically the client, when the client gets the game state, it checks, because remember that I mentioned that one factor to use a Dart backend would be to share code between the client and the server. So that helped us, that gave us the ability on the client to do some verifications. So the client knows when a game is over, but it cannot calculate the result of a match. So when the client realize, okay, the match is over, but I don't have a result, I just call backend and say, hey, can you give me a result? And then the state would be rebuilt and everything would work.
Okay. Yeah, it's funny. It's that's like the allure of non-server authoritative logic, right? It'd be so tempting to be like, well, the client can't figure out a result. Really? It can't decide if it has more points than the other player. It's like, yeah, what if it decides and someone's going to cheat?
Yeah.
And
And super
yeah,
easy, like it's not that complicated to cheat.
right. Okay, let's see. I want to look at some more questions from the chat. Someone a lot earlier, and then again just now. Here's the one from earlier. Asked, where is this code, by the way? What's the repository?
It's flutter/io_flip on the Flutter
It's in the Flutter
organization.
repo.
Yeah.
Flutter io_flip.
Yeah.
Oh, there it is. Huh. I assumed it was a VGV repo.
Yeah, it was, but we transferred before the event.
Oh, okay. Got it. Okay, typing. All right. Well, that's all done. Okay, this question is, I guess, maybe more for Google's end of things. How much time do you estimate was saved using artificial intelligence to generate the images and descriptions? Well, infinite.
Yeah.
Or you said it was 10,000 images and 420,000 descriptions?
Yeah, right? That's the final number of the collection of the game right now.
Yeah. So writing 420,000 descriptions is, I think, basically impossible. Any human beings that you assigned that task to would probably go mad and quit before they completed the job. So you just never finish.
Maybe a few hundred people may be able to, but still
maybe
too much.
And for the images, the interesting thing was the team on Google's end that was making those images really wanted to make sure it wasn't going to generate crazy nonsense. We didn't want very, very loaded, very inappropriate images ever appearing. So it was a model. So Google has this model that's trained only on like responsible, safe, royalty-free, essentially open source images. And so it in theory should be incapable of rendering, some of like images of the worst things from human history and whatnot. You can't ask it to be dash holding, insignias from terrible governments of the past and whatnot, but because it just doesn't know what those are. But it doesn't know what dash is either. So they trained this image on artwork that was commissioned by this design agency that Google and Flutter work with all the time. And they produced these really just stunning images of all these characters. They had quite a few of them. And so then this pretty safe, responsible image generating model, which I believe is called Muse, was tailored or was fine-tuned essentially to learn about Dash and Sparky and the other characters, and then it started spitting all those out. So anyway, all of this is to say the answer to this question is however long, 10,000 images. So how long would it take for that design firm to generate 10,000 images minus how long it took them to generate like 100 or however many they made for the training data, and then like the time spent training. I think again, just a crazy amount of time. But they got it's a pretty cool thing to teach this model. Like basically all it knows how to do is plop these 4 characters in like fantastic, fairy tale locations, and like it's pretty cool. Pretty neat. All right, let's see here. So we've talked about some of the bugs. I'm guessing there's a lot more fun bugs. that are fun in hindsight, and that were driving you a little mad in the moment. What are some of your other kind of just like best battle stories from developing this? What bug had you most confused? Actually, I'll start with that one. What one made you go, how is this possible?
Yeah, so I have one that I think it is not confusing in a way that it was difficult to find or it was a tricky bug to find, but we got one bug reported that the game was not working on Pixel 7. And we started we were in a rush, we were trying to fix, so we had so many things to in your heads to figure out that we didn't even realize that Pixel 7 was not even out yet. So that was the most fun history, I think, for it. Like we tried to debug this bug. We didn't have a Pixel 6, so we tried to debug on that one, but we weren't able to figure out what was not working. And then we realized that Pixel 7 was not out yet. And then, yeah, that was the most fun.
Cannot reproduce. Send Pixel 7.
Yeah, exactly.
Yeah, that was like the owl wasn't showing up, right? Is that the bug?
Yeah, the owl and the card pack animation. So none of those were being shown on pixels.
Well, that is weird.
Yeah.
I don't, it's like the intersection of two very specific things. Something
Yeah,
is going wrong.
we
Yeah, I
tried to
know.
figure
So
out, but
we, Chloe and I, who had that little game, the promo video, we were playing on Pixel 7a's brand new phones, which is, I think the bug report you got was from us. And I hadn't played it on other phones, so I didn't know that it worked on other phones. So I thought it was a mobile issue. And yeah, but we were playing on that, and then for the video, the owl was just added in after the fact. It was added in post, because I don't think we ever figured out what was going on with the Pixel 7s.
It should be showing now, by the way. We made a simpler version, and it should be showing for all mobiles now.
Okay.
Yeah.
Nice. All right, I'm just looking over my notes to see if there are any other thoughts that I had. I think we've pretty much gotten to everything. We talked about how the game was settled upon, the nature of building it in Flutter, having a Dart backend, integrating that with Firebase, server-side authoritative aspects. I'm just running through it all out loud here and make sure we didn't miss anything. Talking to Firestore from Dart, that's always a trick.
Yeah.
But a very interesting detail there about how your server doesn't need to have an open connection, right? One of the coolest things about Firestore is you can watch those games, or you can watch documents, sorry. But the server doesn't need to do that. Certainly, unless it's if it's a RESTful server, if you have something long-lived, then it could. Scaling things. So you got to work. Maybe this can be the last thing, unless we get some more questions from the chat. You got to work side by side with Firebase SREs, and I imagine how much you know about the internals of Firebase and how to profile a Firestore database has gone up an order of magnitude or two. So what's some kind of fun stuff that you learned in that regard?
Yeah, so I still have a lot to learn about in terms of Firestore and Firebase, but I did learn a good deal. I talk a lot with Puff. He helped me a lot trying to understand how to make the Firestore scale better. I think the thing that I really liked to learn was how Firestore collections, they scale in Firestore individually. So Firestore scale everything for you automatically, right? But if when it hit a certain load, it starts to scale to a new tire. So when there is a surge of access into a collection, some users may face like a little bit more of latency because Firestore is scaling the collection for you. So one thing that we can do to avoid that, and we did that for the launch, was to warm up our database. So even though it would not make the game unplayable for anyone, it would make everyone experiences better if you could warm up and avoid those latencies while the Firestore is scaling your collections. So he showed me this interesting tool that is called Key Visualizer, that you can access it from the Firebase console. We will see like more information in Google Cloud. It will take you to a section of Firestore in Google Cloud, and you can see this beautiful heat map about access of your collections, and it shows how much requests per second you have on each collections. And as your database is getting more and more requests, it starts to scaling collections differently. So you start to see what is the tire of the card descriptions collection, what is the tire of the card description, and with that you can decide how to what collection to better scale. So you can identify, okay, so we know that cards collection is one that will be access a lot, will have a lot of rights on that collection. Because people will generate cards, and that's the core thing of the game. So you can go there and decide which collections you can use to scale.
And when you say warm it up, I imagine you mean just spam records into the collection.
Yeah. So there is
whatever.
Yeah, there's an interesting rule. So it's 5,000, and then you can use that proportion for more. So you keep doing 50 operations for 5 minutes, then you go up to 500 per minute, and you keep going if you need to. Then that is usually what Firestore needs to know, that they need to scale up your collection to the next tier. And the cool thing is that once that collection is scaled up to a upper tier, they never go back. So just need to do that once, So if you are really sure that a collection will have a lot of throughput and a lot of operations per second, you can do that beforehand.
Okay, interesting.
I love to learn that.
Yeah. One thing I heard from one of the Firebase SREs was that you can have, Firebase does great at logarithmic scaling, even exponential scaling, but what it will still struggle with is a cliff. So if you ramp up, Firebase can ride with you, but if you go from very little to, because the keynote just dropped your link, then it, like anything, it can struggle. So yeah, that warming up sounds pretty important.
Yeah.
All right, Erick, you have been thinking about nothing other than IO Flip, I expect, for the last 3 months. And now you've agreed to think about it for one more morning by joining me here to chat about it. So thank you. Thanks to the whole Very Good Ventures team for pulling this off. Everyone was working around the clock, like long nights, weekends. I know your whole team we were on the images, or just like on my end, it was the video, but everyone was just kind of hitting it nonstop. Yeah. PTO, Erick. That's the,
I will.
that's what the people want, is for you to get a break. Anyway, I just had the best time working on this whole thing. And I don't know, any closing thoughts from you, Erick?
Yeah, I just want to say thank you for the opportunity to be here. It's super great for me to, having the opportunity to work on this project was already super great, and having the opportunity to share our experience of that project for everybody, to tell our learnings, our faults, things that we, everything. It's a great honor to me. So thank you so much. And if anybody has any additional questions, that I didn't cover, because there's so many things to cover, yeah, I'm pretty sure I didn't went through all, just hit me on Discord, on Twitter, on whatever network that you may find me, and I'm happy to talk more about.
Nice. And your handle is Captain Pixel, right? CPT
Yeah,
Pixel, Pixel.
exactly.
Yeah. Well, everybody needs to follow Captain Pixel
Yeah.
for the hottest Flutter engineering competency you'll find anywhere on Twitter. Okay, Erick, thank you so much for joining. Everybody who tuned in, a lot of great questions from the chat. I really appreciate that. Exhausted
Indeed.
all the questions that we had lined up before I thought we would. So I appreciate that. And folks, next week, I hope to be here. But then Observable Flutter is going to go on holiday for a little bit because I'm going to be in Europe for a long time. I'll be in Paris for the Flutter Connection. Then I'll be in Amsterdam for IO Connect. And then I'll be in Berlin for FlutterCon. And I'm just staying in Europe the whole time. So next week, I think, might be the final Observable Flutter until later in the summer. So, the show won't be off the air or anything. We're not pulling the plug, even though it's going to be quiet for a little bit. But I hope to see you all next week. Erick, thank you so much again. Please go sleep. Go take a nap. And everybody, I'll see you next week.
Bye-bye.